Welcome to our new analysis. For centuries, the Voynich Manuscript has literally been the ultimate historical puzzle, right? Frustrating cryptographers, linguists, historians, you name it. But today, we're skipping the wild theories about aliens, secret societies, or lost civilizations. Instead, we are looking at Rene Lüth's 2026 VRP-3.0 hypothesis. And look, this isn't just another attempt to translate a dead language. It is the anatomy of a strict, scientific working model. We're going to systematically deconstruct this thing to see exactly how it works under the hood. Our main focus? A concept that is often painfully missing in historical manuscript research: ruthless mathematical falsifiability.
Okay, let's dive right into this. The VRP 3.0 model is a massive paradigm shift in how we actually approach the text. You kind of have to forget the whole idea that these weird glyphs form letters and words of a spoken, natural language. The core concept here is actually super simple. One sign equals one recipe, or one specific action step. So instead of arguing that a specific word translates to, say, flower or root, this model treats the text as a functional botanical notation. We are stepping completely away from subjective, poetic translations and moving toward a highly structured set of processing instructions.
So here is our roadmap for today. First, we'll cover the VRP 3.0 hypothesis itself. Second, the three foundational axioms. Third, the stress test, specifically how it handles falsification. Fourth, the operationalized test conditions. And finally, how it functions as a reproducible working model.
All right, part one, the VRP 3.0 hypothesis, beyond traditional translation.
So, the absolutely crucial point to understand here is that this model is incredibly restrictive. It doesn't even try to explain the entire manuscript with all those bizarre astronomical charts or bathing figures. No, it isolates and applies only to the plant-related folios. The main theorem claims the text is a formal, rule-based notation that maps to a closed set of functional categories. Basically, you've got a plant part, a process step, a quantifier, a substance, or a carrier. When you translate that, you don't get a natural conversational language. You get what's called an operational language. Think of it like a programming language or maybe a chemical formula. And here's the kicker. The syntax of this operation stands entirely on its own. It's completely independent of whatever botanical illustration happens to be drawn on the page.
Moving on to part two, the three axioms, the foundational pillars.
Now, these three axioms are the absolute bedrock of the theory, and the stakes here are totally binary. If even one of these pillars crumbles, the entire model dies on the spot. Axiom 1 is invariance. This means a specific sign has the exact same functional role everywhere in the text. Zero exceptions. If you find a context-dependent meaning, the model fails. Axiom 2 is compositionality. Meaning comes strictly from the ordered rules of the signs, not from stepping back and just guessing what the global context of a sentence might be. And Axiom 3 is structural independence. Like we just mentioned, the mapping cannot be influenced by the visual morphology of the plant drawing sitting right next to it. There's literally no room for subjective interpretation here.
So, we've set up these incredibly strict theoretical rules, right? But any good scientist has to ask the next logical question. How can this model actually be falsified? I mean, how do we drag this theory out of the cozy safety of logical axioms and throw it into the harsh reality of empirical data?
Which brings us to part three, the stress test, the falsification crucible.
And this brilliantly illustrates how the falsification actually works in practice. Lüth set three exact conditions with brutal cutoff triggers. Let's look at the if-then logic here. For test 1, if the statistical p-value correlating the glyphs to the painted botany is greater than 0.01, the hypothesis is dead. For test 2, if the text's entropy metrics classify it as a natural language, like Latin, the model fails. In test 3, if an independent blind expert test drops below a 0.6 kappa agreement score, which is a metric that measures inter-rater reliability, it is game over. This is strict mathematical logic, guys. There are no excuses and absolutely no ways to massage the data after the fact.
Part 4, operationalized test conditions, by the numbers.
You know, a truly scientific model simply cannot move the goalposts mid-game. That is exactly why VRP 3.0 predicts the text will have a very specific mathematical signature before testing even begins. It expects a bigram entropy, which is basically a measure of how unpredictable the sign sequences are, of under 2.8 bits, alongside a type token ratio over 0.6. We then compare these numbers directly against natural languages, like 15th century medieval Latin. Natural languages have a specific, measurable mathematical heartbeat. If the Voynich glyphs measure closer to natural Latin than to the strict VRP metrics, the hypothesis is just thrown right in the trash.
So let's see how this all builds into test 3. To ensure absolutely no one is cheating, the model requires a brutal out-of-sample blind test, and the protocol is ruthless. Step 1, you fix the translation mapping using only the first 10 pages. Step 2, you freeze that exact mapping using a cryptographic Git hash. This guarantees you can't go back and tweak the rules later if you hit a snag. Step 3, apply this rigid, unchangeable mapping to brand new pages, specifically folios 11 through 20. And step 4, have 3 independent experts in medieval botany and pharmacy evaluate the results completely blind.
And that brings us to this very specific number, 85. Prediction 3 states that this blind test can't just yield okay results. If less than 85% of those independent experts agree that the machine-generated translations of the new pages make distinct pharmaceutical and botanical sense, the model fails. In the world of historical text analysis, an 85% coherence threshold among blind reviewers is a massively high hurdle to clear.
Finally, Part 5, a reproducible working model, setting the boundaries.
You know, sometimes what a theory deliberately ignores is just as important as what it actually claims. The VRP-3.0 hypothesis makes 0 historical claims about who wrote the manuscript, when exactly it was written, or what the overarching purpose of the whole book was. Was it monks? An alchemist? Just some elaborate historical hoax? Honestly, the model doesn't care. It behaves purely as an isolated, neutral tool built solely to test the mechanics of the plant pages. In a field that is absolutely full of researchers claiming to have solved the entire mystery in one fell swoop, this kind of scientific restraint is incredibly rare.
As Rene Lüth summarized in 2026, this hypothesis is published in its current form as a falsifiable scientific working model. It's not some unshakable dogma. It's not a sensational headline claiming the code is definitively cracked. Instead, it's an open invitation to the scientific community to take the parameters, run the scripts, and actively try to break the system. It is all about scientific rigor over sensationalism.
So, I'll leave you with this. If a centuries-old mystery practically begs you to destroy it with raw math, statistics, and uncompromising blind testing, isn't that the first real step to finally solving it? Because it's not just about proving a historical theory right, it's about having the confidence to build a reproducible model, brave enough to be proven wrong. Definitely something to think about the next time you look at history's greatest unsolved puzzles.